All right, we all need to be paying attention and looking up front here as we go over something. We're going to do a quick review on conductors, insulators, conduction, convection, and radiation. The test should be Friday. The project is due Friday. We're going to add a new topic to the test. We'll go over those notes and hand out those vocabulary words for this week as well. And eventually we need to have a vocabulary quiz on the words as well. If you haven't already taken that, so it'll be something as we move through this week. Yes? Hurry up. All right, so as we look at heat exchange, which will obviously be a giant portion of the test. Let's see, this device only. Then go back to this. So I want to start with conduction. I'm going to start with conduction. I don't know why that was backwards like that, but it is what it is. Conduction will definitely be a part of the test. We know that conduction is heat when it passes through a material like by touching. What are some examples that we're most likely going to see on the test about conduction, Victoria? An animal lying in a cool patch of dirt. Yes, most definitely. If I can get that on the test, I'm going to put it on there, Ellie. The what now? The ways we did what? Yes, I mean, I won't put that on the test, but the way that we write conduction, convection, and radiation will be helpful on our memory dump. So when we write the word conduction, we underlined the word D, wrote it in a different color, and then that stood for do not touch the hot stove. But what are examples that might be on the test? Cooking an egg in a pan. Ice melting in your hand. Evan. Touching something hot, whether that's like you touching the belt buckle that's hot on a summer day inside the car, whether that's the you touching the stove. All of those things are touching. The ice is touching your hand, and therefore the heat's moving from your hand to the ice. All of those things are about touch. So cooking egg on the stove, ice melting in your hand. If you're stirring coffee and you touch the spoon and it burns your fingers, that's through touch. That's conduction. And then an animal laying on a cool patch of dirt is important as well. Convection will also be a big portion of the test. We know that convection is when heat moves through a gas or a liquid. What are some examples we might see on the test of convection? Joanna? Boiling water would most definitely be on there. Sky? Thermal energy moving around the earth. Let's talk about that a little bit. And so I have this on the board. So we're at the beach, and then here's the water. Terribly drawn, but it is what it is, right? During the daytime, we all know that the sand is pretty hot. Would you agree with that? So we have the air above the sand is going to be hot, so we have hot air rising. Typically, when you get into the ocean, it's a little bit cooler than the sand. Would you agree with that? Yes. And so the air above the ocean is going to be a little bit cooler, and we know that hot air rises and cool air sinks. Now, here's the thing that we didn't really think about is as this hot air is over here, and I don't know that it's going to let me do this because it would on the other one, but there are little molecules of hot air that shouldn't be blue, that should be red because it looks like it's different. There we go. There's red. Can you see the little molecules of air? This pen is not working very well, but can you see them? Well, if they are hot, typically what they want to do is, and I can't even pick this up like I could on the other, but they want to go up, leaving an empty space here. And what happens is those cooler molecules are coming down. Why did that change? Did that change colors on me? Oh my goodness gracious. There we go. The cooler molecules are sinking over here, and because there's more molecules here, they are going to move not in red. Goodness gracious thing. They're going to move this way. And because it's moving from the sea to the land, this is what we call a sea breeze. Correct? Okay, that's a convection cell. Can you see the hot going up and the cold coming down? The same thing that we saw inside of the jars when we did the experiments. Conversely, during the nighttime, we go back to the beach. Does the sand feel a lot cooler than it did during the day? And if you've been in the ocean, you know that the water feels kind of warm. Well, the ocean's been absorbing heat all day long. So the opposite is going to happen. Your warm air is going to be above the ocean going up. Your cooler air is going to be above the land coming down. And the air is going to move this way. And because it's moving from the land to the ocean, you have a land breeze. That could definitely show up on the test as well. It's something that we've kind of talked about over time. And if some of us have even looked at that in class. Hot air balloons. Hot air balloons are all about convection, right? You put hot air into the balloon, the hot air goes up. As it cools off, it comes back down to the ground. Otherwise, we wouldn't get in those balloons. It would be a very wild trip. So again, boiling an egg, movement of thermal energy. We've talked about radiation will most definitely be on the test. What are the two most likely questions that we're going to have on there? Yes. How does it transfer? There's two big examples of this. Sun heating the earth. Sitting beside a campfire. Again, are there other examples of radiation other than the sun heating the earth and getting warmed by a campfire? Absolutely. I know that we saw the one about a pet lizard inside of a tank. Typically, you don't put the pet lizard outside and let the sun heat up the lizard, and you don't build a fire inside of the tank. You put a light bulb in there, right? And the heat radiates off the light bulb down to the lizard or snake in the terrarium, and it keeps it warm that way. There are other examples. I know we saw that one question on something about if you went outside near a brick wall, a dark colored brick wall, and you could feel the heat coming off the wall, that's radiation. If you touch the wall, that's conduction. So again, radiation will be on the test as well. Oh my goodness gracious, pause. We also have conductors and insulators. Conductors and insulators will definitely take up a portion of the test as well. And conductors are things that allow heat to move through them very quickly, like metal. What are some times that we want heat to move through something very quickly? Sydney. If it's something's cold and you want heat to move through it very quickly, that would be one. Jason. Cooking, like the pots and pans that you cook with, you want heat to move through them very quickly, because you want to be able to cook your food fast, correct? You don't want to put the burger in something that's going to take 7 days to cook. That would not be a good thing. If you want to cook your steak or your burger or whatever, you want to put it in a metal pan, because we know that heats up quickly, therefore allowing it the heat to pass through it, and you can get your food up to temperature fast and be able to eat. Those are conductors. Metals are conductors, right? Metals are conductors. So that's something that we'll talk about. There's also the opposite of conductors, insulators. We all just went outside. It was 40 degrees outside. Most of us, at least the smart ones of us, were having insulators on when we went outside. We had our jackets on because we wanted to keep the heat near our body. We wanted to keep the heat near our body, and we didn't want it to leave our body and move out. Our houses are the same thing, right? During the summer, we don't want the heat to come in. During the winter, we don't want the heat to go out. So some of us have we've talked about that pink stuff that we've seen in the attics or in between the walls that will make you itch like crazy if you mess with it. That is an insulator. It doesn't have to be pink. There's yellow and other different colors out there as well. I know when we had to climb up on the roof for our experiments last week, it's yellow in the ceiling above us. That's keeping our room warmer right now. It's keeping the heat inside and the cold outside because it's an insulator. An insulator. You also want insulators on the ends of those pots and pans that we talked about. If I'm cooking and I go to pick it up and it's always hot, I either want to have a handle made out of wood or plastic, or I want to put on an oven mitt because I do not want to burn myself. If I'm stirring things, like a boiling pot of water or something, I probably want to use a wooden spoon or a plastic spoon, or at least a spoon that might be metal with a handle made out of wood or plastic, because those are insulators and do not allow the heat to move through them very quickly. Yes. Again, insulators do not allow heat to move through them very quickly. Conductors do allow heat to move through them very quickly. We have radiation, conduction, and convection that will be on the test as well. Any deep questions about those words before we move on? Going once, going twice, nobody at all.